Yeah, so for our last talk for tonight, we're going to have Maricris Nonato talking about coding confidently with grouping. Give her applause.
I'm very happy to see a huge number of attendees for tonight. Hopefully the new formats will encourage more people. Anyhow, this is the talk I gave at the last Philippine, which was held at Boracay. So again, I'm Maricris Nonato, which is talk at Maricris Vice President. So let's start. You can also find this talk at speaker deck or through this URL. So I'm working with Premier Speakers Bureau and we're hiring. This is my floor, okay? So please get in touch with me via Twitter if you're looking for a job or looking for a junior developer. So what we do is Premier actually helps you make great events by giving you the opportunity to book world-class speakers. So we take pride in the speed and the efficiency of our service. We even handle last-minute bookings for your events. So check us out if you want to make memorable and inspiring events. So I'm actually here to whine about something before I give this talk. I want to whine about TDD. So before it became a big fad, everyone just immediately took it into their practice to do TDD, to write code, to write tests before they write the codes. But in my experience, when we tried it before with my previous company, it didn't produce very good results. Like the code was inelegant compared to the tests. The tests were a huge ecosystem of working stuff hand in hand. There has been a lot of improvements, more gems and stuff for producing good tests. But the code that, consequently, the code that they produced was not very beautiful. It's more like it's just satisfying the test. So it passed. The tests passes. The tests pass. But it's not necessarily the best thing that we would want our code to be. So we can sleep at night knowing that there won't be anything that's going to pop up over the night or something. But it's not the optimal code that we are expecting. So I kind of didn't like it. And I'm very happy right now that I'm hearing more thoughts about TDD, about how to fine-tune TDD, how tests will more likely work with your entire application instead of just going forward with test-driven coding. So I know that we are all super duper awesome programmers to begin with because we are here and we are working with Ruby on Rails. But it's another thing to be passionate about what you do. It's like you're doing this, it's working out for you, it's part of your day job, but what are you doing to improve your craft? So in order to be passionate, you must first fall in love with your work. Just like a sushi master, you should learn new things about what you do, and always come back to your old code and see how else it can be improved, like runtime, speed, performance. If there are new gems, you should come back and top it up, see if you can still make it even further beautiful. Sorry. So your code actually tells other people, you and your teammates, a different story each time. So you don't want your code to be like an adventure book. You want to beat the troll now, turn to page. If you want to go to the cave and do this first, go to this page. You don't want your code to look like that. Like you're jumping around, trying to understand how this flows. It should be very easy for someone new to jump in and understand what your code's doing. So that's what your end goal should be, especially if you're working with a team. So this talk is going to be divided into 3 different parts. The biggest part would be about data inputs, and the least part, the smallest part of it would be the exceptions and error handling. You would see that later on this talk is greatly inspired by a book written by Abdi Grimm. It's more about the patterns that you can quickly pinpoint, that you can refactor in your code. So our code, our application is always always about data. Whatever code you write, I'm sure it's going to pass. But given the bad data, given the data that doesn't fit into your code, it's more likely going to crash. That's why you should be proactive enough to catch that beforehand. So,
More cats.
well, we love cats.
Yeah.
Who doesn't, right?
No cats, Mario.
No cats. Anyway, so first off, your friendly neighbor will be its conversion methods. Our common comfort zone is to use conversion methods to make our objects work together and not produce an error. However, do you guys know how to properly use it? So this is a matrix of the common conversion stuff that we usually use. So you can see that there are duplications of different conversions, like converting to an array, converting to an integer, or converting to string. The difference is explicit versus implicit. Explicit is a less stricter conversion, and Ruby doesn't call this automatically for us. Implicit conversion is used only by Ruby's core classes and enforces real conversion to the target class. For example, int, in other words, should be used for classes that can be used as an integer. Think of explicit conversion only as a means to avoid failure. Later, I'm going to show you why. There are different behaviors of these conversion methods depending on the input class given to it. So the only time that Ruby can automatically call explicit conversion for us is during string interpolation, which I know you guys usually do, in which to s is called for each variable interpolated. So let's say that we have this class. So my examples are very, very simple because it's very difficult to actually think of an example for presentation. So let's just use cat for this. So we have this class and we're going to instantiate one. Okay, so I'm now going to attempt an implicit conversion. I'm giving Ruby the chance to do the conversion for me. So the cat there is a cat object. So it doesn't know what to do with the cat object because it's going to attempt the implicit conversion. The explicit way is to actually call .s, which will give you this memory address of your cat instance. So it's going to look like that. That is the explicit one. Implicit will always fail because it doesn't find the exact conversion we're trying to do because Ruby will not guess it for us. So there, this is the string interpolation. This is the only time that Ruby will try a 2s for your instance method if you put it in a string interpolated statement. Sounds like a doc, must be a doc. In Ruby, we rely less on the type or the class of an object and more on its capabilities. Hence, doc typing means an object type is defined by what it can do, not by what it is. Okay, so again, simple classes for the sake of demonstration. So we have a doc class and a doc recording. For the sake of illustration, we are showing here that it doesn't matter whether it's just a recording or an actual doc as long as it's quacking. So if I call make it quack on a real doc, then it quacks. And if I call doc recording and pass it to make it quack, it still quacks. So it doesn't matter as long as the object is responding to what you want it to do. Okay, so now what's the difference between high tech? It's not as fun yet. Hold on. Okay, so although we love doc typing, we can also incorporate the use of respond to at the same time. By doing this, we can still go on with our code without having to check the type of the object. Checking the type of the object every time is tedious, especially if you don't know the range of objects you're working with. So we just want it to behave as we need it. So again, we're working with the same class, the doc. Now I'm adding a cow. And still the doc recording. Okay. So now I'm going to illustrate passing the animal and try to see how to make it quack. Now, if I don't know what the kind of animal is getting passed to our method, I'll have to check it every time. Is this a cow? Is this a dog? Is this a dog recording? So it's very tedious if you do that. So how can you make it better? This is the first solution. You can check whether this object responds to quack. So regardless if you have 20 farm animals in your class, and you just want to find out which one can quack, you can do this. Or you can create a catch method, which will switch depending on what the animal sounds like. So cow can just have a moo sound, and the duck can just have a quack, so you can call it a sound off for the animal. So it doesn't matter what animal it is. Then don't act like it, be like it. Beyond the conversion methods that have been discussed earlier, there are also conversion functions, which are more stricter. So Ruby has several literal conversion functions like national, array, string, pair, float, complex hash, and hash has been added in Ruby 2.0. So this is a little stricter. Okay, so I'm going to show you why. Okay. So the first column converts the given object to a usable integer value. So I'm just going to focus on the integer here and compare it across different responses. Then the second column does a quick check on the input class to find out whether it is usable or not. And the last column is more of just conveniently avoiding failure. So the last part is the one that I have mentioned earlier, where you're just trying to avoid failure when you're trying to display your object along with another class. So you can see here that the conversion literal integer is a lot stricter. It can determine conversion, whether you're passing a string, a decimal, an octal number, or a binary number, and even time. So, but given a string like cats, it will fail and cause argument error because it doesn't know what to do with it, because it doesn't have an integer value to return. So, and then the second column is the implicit type of conversion, which is still not accurate. You can see that it fails on all of the strings. And the last one is just returning 0 if it doesn't know what to do. So you should be careful about implementing these conversions in your code. So especially if you are working with, say, e-commerce related products, so you have to watch out for that. So it's better to use the conversion literal integer. So if it's not enough, then you can go make your own. So convenience method for conversion method for convenience. Sorry. So sometimes it would be easier to just create your own, especially if you use it frequently. So this is just an example again. So let's say that you have a point, and every time that you are given two values that represent a point, you want to output location at x and y. So instead of doing that every time, you could just create a class which responds to that and return your own conversion method.
Exactly.
So that was the coordinates for Boracay lesson. And then you could use a more strict function. So this is another example. So let's say you're a fan of Bitcoin and you want to return the money on the wallet, peso plus Bitcoin, given those values. So while this works fine, you'll have to worry about converting your peso to a float and your Bitcoin to a float. The multiplier there is just imaginary, just to illustrate the concept. So you'll have to do either the first one or the second one, but there is some other way better to do that. So you see here that I'm now introducing my own literal, which is peso. So I did a class Bitcoin and class peso here, where in the peso class, we just always return a converted float for your input, so that you don't have to worry about doing that conversion every time you call your methods. You just call peso literal to convert your peso input, and then Bitcoin that to peso. So something like that. And then another one is if it can fail, it most likely will. So you should just fail early and catch the problem. So let's say you have a person class, and then you have these methods for that class. You're checking against if it's minor, and you're checking the age, returning the age. So instead of doing that all the time, you can see here that there are begin rescue blocks, there are a lot of if-else going on. Most likely you're going to produce the same code for every method that you're going to work on for a class person. So instead of doing that, what you can do is you can check for the part that will always fail. A person will most likely have a birth date unless you don't know when you were born. So you will have to set this beforehand so that before you create your person class, you will always have someone who has a birthday. So this is an illustration. So if you do the first part, you always get an error because the birth date is not given in the right format. While on the second part, you pass a date and you get the right person class. So rewriting the earlier code, you will now get something like this, which is a lot cleaner, and you don't have to repeatedly check for the birth date for every function. So this is the function earlier. That was very long before. And then the power fetch. So this is something that you do with hashes. Hashes are a very strong data structure for containing a lot of information. You can mix and match your keys and your values, but there is an ambiguity for getting the value for key that is not present. So this is an example. So we just have foo and bar, but if you're testing for the presence of foo bar, you will get that H foo bar in spec will always return nil, but it doesn't tell you if is there a foo bar key or that foo bar is actually a nil value. So that is where the ambiguity comes in. But what you can do is use a fetch instead of that, so that when you try to get a value using a key that's not existent, then it gives you a key error instead. So this is more precise, so you know every time whether you're working with a non-existent key or not. And then you can customize it further by supplying a error block. So these are the different formats of fetch. So the second one can assign a default value if there is no value found for the specific key. And the last one is by executing a block if the key is unexistent. So this is how you execute it. Okay, so sorry guys, this talk is very technical. It's kind of long, so it's very good. So another pattern is using special cases as objects. So we've all used authentication modules like device, right? So there are particular scenarios that might be just going on under our noses, and we've been ignoring it for the longest time. But in Abby's book, I found this example very enlightening. I think it's really good. So I'm going to share it with you. So this is the common current user method, and then you have different methods using current user. So you can see here that if the current user object is not containing a real user, or it's just a guest, so you just return anonymous. And then you do another if-else here using the current user object. So while this looks like it's okay, in the long run, if you keep using your current user, you'll get a bump that there's always this if-else block that you have to work with. So the solution presented is to create a special object that will handle the case wherein this is just a guest user. So we're just going to create the guest user class. And then the sad part here is that we're going to create a method for each one of the methods of current user on device that you're more likely going to use. So you have name, you have is it authenticated. So your guest user method will now look like this. So it will just return the user if there's one, and then just the guest user for a guest logging on your site. So it saves you a lot of time and probably saving you from RSI. So instead of using a lot of if-else to check your guest or your current user, then by doing this, you could handle all of your cases just like as it is. Just return current user name. In Ruby, our data types may have a value of nil, which means it's empty or it doesn't exist or it's a type of nil class. While it's perfectly fine, it may cause you problems if you did not anticipate the absence of something. So again, let's work with the class person, and there's a nickname, and then there's the render details. So sometimes a person doesn't have a nickname, like if your name is just like one syllable name, then it's probably also your nickname. So you don't have to specify another nickname for that. So what you can do is just make a fail-safe. So for every time you call nickname, you can either get the nick from the database or just return the first name or something else that you want. So that you don't have to repeatedly check for it, or it doesn't crash if you don't have a nick for this particular person. And then the next part is bundled together. So while Ruby doesn't enforce strict rules about how many parameters you can pass in your method, it will look already to have really long list of parameters. So it can quickly become confusing in terms of ordering, naming, and even class types. So what you can do is group together all of the parameters that you'll be using. So for example, you have plot class, and it can draw a line or it can draw a triangle, but you can see here that the parameters passed are just points. Points that can be like point A, point B, and point C. So in order to make it better, we just identify the nature of the input points. We can remodel our objects by making a struct for our point. Okay, and then we create a line class and a triangle class, and then just pass the points there. So it will clearly give you an idea of what's happening here. Although this might look very tedious, like you just created a bunch of new classes instead of one or two like earlier. This is clearer, again, in terms of communicating what you mean or what your code does to your teammate or even to your boss. So ideally, we design our methods to be lenient to the inputs we'd like to accept. As we have seen in the earlier slides, we can maximize the use of the typing, conversions, etc. to aid us in making our methods more lenient but robust. So we're now going to the second part. So we've covered about big bulk of data inputs. We'll now look at how we deliver our data. So in mathematics, there is a term called total functions. These are the functions wherein any kind of input you give it will always return the same kind of output. See, somebody there is nothing said. Very ferocious. So in best practice, we'd like to put this into habit because it makes our code predictable, and hence it's going to be less error prone. So this is an example of a badly written search method. So given a hash parameter, you're checking for a lot of different scenarios and then returning different kinds of output depending on the case it falls into. So what's wrong with this method? Although there's really nothing wrong with it, this method will return you either nil, a zero, or a JSON file and an array. So while that's fine, it's not the best of practice we'd like to form. So this is an example of an API. So most APIs you see are always returning arrays, diba? Either it's an empty array, it has a value, but it's never a nil, it's never a zero or something, but it's always an array. So at this point, you have the perfect use for a total function. So an API, again, will always return the same class every time. So our search method, if we rewrite it, having the total function in mind, will just end up with two lines like this, and your output will always be an array. So regardless if the JSON file, the result is empty, it will always just return an array. If there's something, some records found, then return the records in a JSON format. So So we have just trimmed it into 2 lines. And it's also now a total function. Okay, graceful exit. When your method is meant to do only one thing, fulfilling only one condition, you can save time and effort by returning early when the condition is not satisfied. So let's take a look at this. So you have a specific condition here, whether you're going to do something or not. So it's for every time that you use a block like if else or unless else, you're supposedly giving equal importance to both blocks, right? So by doing this, you're already saying your mindset is just looking at this one scenario. So the right way to do it, or the better way to do it, is to just reject the cases that you don't want to work with and just proceed with how it's supposed to work for those that are not included in the matched scenario. So instead of having blocks that are like cut off. Okay, and then the last part is now about errors. Sometimes even if we coded legibly, our functions are working well and we did all of the best practices, there is still a case that we're going to handle some errors. So these are some of the tips given in the book. So you throw, I'll catch. Well, throw is not actually the best of catch, the best of begin rescue for some programmers because they think that it's like a go-to statement. It's the best way to do, it's the best thing to use if you're going to get yourself out of a deeply nested method. So for example, okay, given this, I just took it from this link, so you can check it out. What this does is it tries to find the gummy bear from the floor, so there's a pile of floors. So instead of you trying to finish the entire block every time, you could just get out of the block by using a throw. If you find what you're looking for. So that's what the benefit of using throw is for. So you can get gummy in just for a minute. Furthermore, there are other formats that you can use with throw. So you can also cascade blocks with throw. So you can use like this, and still it will return gummy just for a minute. So, and I think this is the last. So we can rescue from specific errors to general ones. So this is just saying that the format of a begin rescue should start from rescuing from specific exceptions, going down to a more general exception, and then ensure block will always be executed. So you don't raise or throw an error inside an ensure block. So this is an example of a buggy method, and then say that we have this begin rescue blocks here. We can further improve this code by solution 1, either recapture the code separately if you have a lot of begin rescue blocks, or you can immediately rescue after the block that you take to throw an error. So this is a lot cleaner and easier to look at. So again, the book is the talk is inspired by this book, Confident to Me, by Abby Graham. And you can further read on about these patterns for working with your code by reading this book. Exceptional to be there. So questions. I'm sorry for the very long talk. I was hoping for this was done for a 30-minute talk on the economy. Yeah, questions?
Question.
Yes.
So do you think it's possible to prevent bad data?
No. Because the real world, bad data will always be there. Actually, I would stand to be corrected because I think that you are not supposed to attach bad to data because data is just data as it is. But we get the data that we're not expecting if the code produced it. So for example, you have, this is probably a common case, you have 2 different applications working with the same database. Application 1 is trying to check on this particular field, enforcing validations and stuff. That's why it will create the right kind of data that you're expecting. However, if the application 2 works with the same database and then it did not enforce the right validation, so it does not create the right or the proper data in your database. So while this produce different results in your database, it still cannot be called bad data. So the reason it becomes bad is because of the application that reads it. So you say we create a third application and we're trying to look for, let's say, a date for a birth date, of course. But then application 1 and application 2 created it or stored it as a string. So that data now is bad in the perspective of application 3. Did I answer your question?
Yeah, but we don't want to design something like that, right?
Of course.
So you can prevent that before deploying something like that.
Yes.
An application.
That is also why the first part is kind of packed with information, because the first part is more about data inputs. So it will guarantee that you will always put in the right data in your database. Questions? Thank you guys for bearing with me.